This is a video here I had no intention of making. This is a Tascam 122, the first model, the unmark model or no mark model. I wish Tascam hadn't have done that whole Mark II, Mark III business. It just confuses people. But this is the transport out of the 122, which is like the TX C3 series, and very well built transport. But I had run into some interesting issues, and so I didn't have video of it. This is the belt residue on the Capstan Flywheel, and I didn't think too much about it in the beginning until I scraped it off and saw that this bubble pattern wasn't exclusive to the rubber material. And that's when I decided it was sponge worthy and got the video camera out. So right here you can see that bubbling is in the actual plating on that cast steel flywheel. I don't have any idea why. I haven't seen anything quite like this before, but it's definitely there, and a problem I want to take care of. So I've got it chucked in a precision Pratt Bernard adjustable chuck here, and what I'm doing is I'm dialing in on the capstan itself. This is a 0.5 reading indicator. I'm just trying to line it up so the camera can maybe see it better. And my procedure on this is to go from one end of the shaft to the other and bump it in so that I've got minimal run out. And then I'll turn a very small amount, basically just the coating that's bubbling off of the perimeter of the flywheel. Now I want to take the time and get this really set up as accurately as possible, and that will make the diameter of the flywheel very concentric to the axis of the capstan. So there we go. I think you can see that now. It's not very visible, but at first I was thinking maybe somehow the rubber in the belt reacted somehow with the coating, the plating. And it's, like I say, it's not really visible too much here, but it's also in different areas on that pulley. There's maybe a little bit of a shot of it on the backside. It's not just exclusive to the perimeter. It has it in other places. So this could have been a plating defect. I don't know, but it has to come off. Number one, it will wear the belt out terribly quickly. And number two, it's also not uniform. There's more of it on one side than on the other. Where I've got the little red dot there, it's a little higher than it is on the other side. So it's also knocking it out of concentricity, which is not good for the flutter. Now let's see if this thing will stay focused or not. My advice is, if you're going to do videos, buy a video camera. Don't do like I did. So I'll just touch off on this, and my goal is to take absolute minimal amount I can, because these flywheels are also balanced. Now my total run out on the indicated run out on that capstan shaft itself was somewhere in the range of 2 10,000ths, and that's about as close as I think I can get it. And I'm also expecting it's much closer than what the factory tolerances were on it. So here I'm not even getting it all off. I'm just touching the very outside of those bubbles. I'm just popping the bubbles here. Come on, camera. There. You'll see I didn't even get the plating completely off. Just hitting the high spots. And you can see the how tiny amount of eccentricity, but it's there. And that's expected. I mean, they don't dial these things in at the factory this closely. Probably 1,000th or 2 is good enough. Maybe more. I don't know. Looks like I'm picking up most of it here. I'm trying to take off about, somewhere a 0.5 per turn. I'm just barely bumping the dial. One more should do it, I think. Speed that up a little bit. And I say this is cast steel, not cast iron, because of the way the chips are coming off of this. And I'm really not taking much of the original metal off. I'm mostly taking the plating. So now the side benefit of this, of course, is going to be a much more concentric and round flywheel than what's ever been on this deck, and probably what's on most decks. And in the end, it really did give me some excellent results on Wow and Flutter, down in the 0.4, 0.04 range. I didn't make a video of it, but it was better than factory spec. And these decks still have factory belts available for them, and that's another big factor. I'm just going to polish that off, some Scotch-Brite, and then just break the edges. Going to clean that here with a little IPA. This is no longer plated, and so it needs a coating on it. And I'll use a little bit of steel bluing just to give it a little corrosion resistance. This is Brownell's Cold Blue. dry it off, and then just polish it up a little bit with that towel, just dry paper towel. That was just IPA, cleaning off the residual. Spin it up a little faster here and just give it a polish. Dry paper towels have a little abrasive property to them, and sometimes they're just the right ticket for polishing up something lightly, very finely. And then just a touch of synthetic steel wool, finish it out. And there it is. Now the other thing I had to deal with on this is the split counter pulley, which is common. Nylon pulley will split over time when it's on a steel shaft. It can be bonded to the shaft. That's one way to deal with it. The way I like to do it is to turn a small brass sleeve. It requires turning the magnet just a little bit. It's only a couple thousands. It's not very much. It could actually be sanded. Just test fitting there. And it makes a nice job out of it. That won't have to be dealt with again. That's how it ends up, and then the magnet just gets bonded on that brass sleeve. It's a good repair. And then while I've got this counter out, I clean up the mechanical gears and just put half a drop of dimethicone or any synthetic oil on that shaft, and then kind of rotate it around there. I don't want to use any oil-based, petroleum-based products on this. Just silicone, something like that works great. So there's that little bit of an unusual finding on the Tascam 122, and a way to deal with it. Thanks for watching, and stay tuned for more.